If you watched the last video, you'll notice that I have covered most of the solution questions in class, so we're going to go on and go to the next page, talking about solutions again. This time we're going to talk about the effective temperature on solubility. So remember, solubility has to do with how much of a solute can be dissolved in a given solvent at different temperatures. The solubility for most solids, not all, but most solids, it is, solubility increases as temperature increases. Okay. Now gases, however, gases have decreased solubility as temperature increases. So let's talk about why solubility for solids as the water molecule or the solvent, whatever it is, as the temperature goes up, the molecules move more quickly, and as they move more quickly, it is easier for them to separate it out. However, with gases, it's the opposite. The gas molecules are already moving fast enough. If you increase temperature, it is harder for them to be trapped in. So that's why most things have that relationship. Solids are more soluble with temperature increases, and most gases are less soluble as temperature increases. And you can see that if you take a look at one of our solubility curves. So this is for multiple different solutes in water as a solvent, and the temperature on this graph is going from 0 to 100 degrees. Beyond that, we don't have water as a liquid anymore. And it is given in grams of solute per 100 grams of water, but that could easily say grams of solute per 100 milliliters of water, because 1 gram, just sort of remember, 1 gram H2O equals 1 milliliter, okay, at normal temperatures. Okay, so what amount of ammonia can be dissolved in 200 grams of water at 10 degrees Celsius? So we need to figure out that ammonia is NH3. So if you see, NH3 is one of the ones that has a inverse curve. If you guys can see it, it's that guy right there. Please make sure you're following along in your own packet. So NH3 at 10 degrees, if we come up here, we look at it's just below 70. Let's call that, looks like about 69 grams per 100 grams H2O. So if we have 200 grams, we could do twice that. Is that 138 grams can be dissolved. All right. The next one is a solution of 80 grams of KNO3, so that would be potassium nitrate, at 40 degrees, saturated, supersaturated, or unsaturated. So first thing we have to do is find KNO3 on our graph. KNO3 is this big swoopy line coming up here, and then we have to find 40 degrees. So here's our 40 degrees. We go up, and it looks like right about there. So that's just above, like about 62. So if we had 80 grams, that would be on this side. Oops, sorry, 80 grams, that would be on this side right here. So at 40, I could only hold 62, and I'm actually holding 80, so that would be supersaturated. If we were over here and I was holding, less, then that would be unsaturated. All right, if we have saturated solution of 1.5 molarity, so we said saturated, so there's a clue right there, 1.5 m sodium nitrate. So sodium nitrate is NaNO3 right here along that line. What's the temperature of the solution? So we first have to figure out how many grams of sodium nitrate. So we have to go back to molarity. So let's go with 1 liter. So if we have a saturated solution, 1.5, and we had 1 liter, that would mean we'd have 1.5 moles. Each mole of sodium nitrate is, a calculator, sodium is 23-ish according to the periodic table, so we've got 1 of those. Nitrogen is 14-ish, got 1 of those, plus we've got 3 oxygens, for a total of 85 grams per mole. So if we do moles times grams per mole, let's see, 1.5 times 85, 127.5 grams, but that would be in a liter. How much is a liter? A liter is, so per, let's write that, per liter. This is per 100 grams, or that would be 100 milliliters, or 0.1 liter. Remember, milliliters divided by 1,000 gives us liters. So if I'd have 27.5 grams per liter, I'm only going to have, let's move that decimal, boom, 12.75 grams per 100 milliliters. Let's see, they said, what's the temperature on this line? That's going to be down here, so that would be not really possible, right? If it was a full, if we move that decimal over, we'd be over here, but that would be very unsaturated. Right. Okay. So I'm going to stop this video here. The next bit is going to be on acids and bases. We're also going to cover that in class over the next couple of days as well. So please be keeping up with your notes both at home and at class.